revision or look at some like typical questions or something like that.
Or yeah.
So I know I said I'd do some on the line yesterday, but basically I ended up trying to do up the notes, which for some reason I hadn't done before, and there was quite a lot in it. So I can kind of run through those, or if there's other topics you want to go through. What do you feel yourselves?
I really don't mind.
Okay. Jack or Andre, anything you want to go over? Yeah, okay. The best way to do the, yeah, Jack?
No, there's nothing specific.
Right. So the best way to study for maths exam is, like, remember that what I'm going to do is, in case you don't have your own tables, I'll put up the link to the ones online, so you'll have all the formulas that you need in the maths tables. I'll give you the, as I say, the online version. So your best way is to go and try questions. So what we could do now is maybe look at a couple of questions, say, on the line, and just how you would approach them, and then maybe some on probability. So let me just pull up that. Okay. Can you see my screen okay?
Yeah.
Yeah. Okay, and I'll just run quickly through what I've done on the notes so far on the line, where I'm almost done with them. So, jump to the line. Okay. So we talked about a lot of this yesterday. Can you see this on my screen?
Yes.
Okay, so the line, basically the whole thing is you have the same relationship between x and y. Big thing with the line is its slope and where it crosses the axes. That's how you tell one line from another. Parallel lines, perpendicular lines, steeper lines of higher slopes, lines that slope down of negative slopes. The equation for line, okay, so you can have general form or slope-intercept form. The general form is good if you're doing something like simultaneous equations, like where to find two lines are crossing, or for some of the formulas, like if you're getting the distance from a point to a line, you want it in this form. Slope-intercept form is more useful if you're kind of looking at the graph of a line, because immediately you can relate it directly to the graph. So you can see the slope from the graph, and you can see where it intersects the y-axis. So that's your M and your C directly from a graph. And then just be aware of special lines. If a line goes through the origin, then it contains the point 0, 0. So if you sub in 0 for x, you get 0 for y. So there's no C. C would be 0. Okay. Anything parallel to the y-axis, you just have a constant. Parallel to the x-axis, y is constant. That makes sense? That's your vertical and horizontal lines. And the equation of the y-axis itself is x equal to 0, because that's what every point on the x-axis has, and the y-axis or the x-axis is y equal to 0. This little question here, I think we did one similar on. Let's make that a bit bigger. Sorry, I'll see if I can put in a better picture of that. If you're given graphs and you're looking to compare lines, okay, what you want to do is use the slope-intercept form. So if you're given a few equations, put them into slope-intercept form, okay? And when you look at the slopes, are they plus or minus? So we can see here that 3 of these lines are plus and 1 is minus. So we immediately know that this y equal to minus x, sorry, it's not very clear, but that's this line here. So you could fill in that one first, okay? And then we could see that these two, P and R, are parallel, so they have the same slope. And we can see 2 of them begin with 2, so their slopes are both the same. So you could fill in those 2. And then that leaves the final one, this one here. Okay? Does that make sense?
Yes.
Okay. And, you know, if you might have like a typical leaving cert question, might have 5 or 6 of those lines. So you really want to, you know, look at the slopes. If you were telling, say, P and R apart, you can see that they have the same slope, but how do we know which is which? Then you look at the intercept. So you look at the slope first, then look at where they're crossing the y-axis. Okay, so the difference between P and N here is that P is going to have a plus for its C value, and this one, or, is going to have a minus for its C value. Does that make sense? Yeah. And if you have a line, let me just go to my camera. Yeah. If you have a line that's in general form, so if you have y is equal to say you have 3x plus 4y minus 6 equal to 0, something like that. To get it into slope-intercept form, you're going to move the x and the number to the other side. So you have 4y is equal to minus 3x plus 6, and then you divide by the number in front of the y. Okay, and that will cancel, and there's your equation. Okay, so you can see the slope here be 3 over 2, and it'll cross the y-axis at 3 over 2. Okay? Everybody happy enough that they're able to do that? Okay. And that's actually more junior cert stuff. And then if you're missing like an x or y value, you can find that, if you're looking for coordinates of a point and you have either the x or the y, you just sub them into the equation to find the missing one. So if this contains the point 3k, don't be put off with k being a letter. That's 3 is your x value, k is your y value. So you put 3 in for x, k in for y, and you get an equation that you can solve for k. Same thing with that one. If you're asked to find the intercepts, that's where it crosses the x-axis and the y-axis. So where it crosses the x-axis, y is 0. So you just sub in f of x or y is 0, and you find your value for x. Sub in your x is 0, find your value for y. Is that okay? And if you're asked to show that a point is on the line, you take the x and the y values and you sub them in. So if you're asked to show that the point 3,5 is on this line, if you sub in 3 for x, you should get 5 for y. So you put in 3 3s is 9 minus 4 equal to 5, which is the y value. Therefore, the point is on the line. Okay. Now, these all the formulas you need are on page 18, 19 of the tables. Okay. There's the 4 ones that you would have learned for junior cert: length of a line segment, midpoint, slope, and equation of a line. Okay, so you need to be able to use those. And then what I want to do is kind of focus on the newer ones. So the other equations in the tables are the point dividing a line segment in the ratio a to b. So I'll do a couple of examples with these, okay? So let's say we have, let me just take this down and then U is 4, -3, distance 2, 3. Okay, so these formulas here really are the ones you want to focus on for the test, okay? So I'll go through an example of each of them. So if you have 2 points, P and Q, we can call them P and Q, and you want to find a point that divides that line segment in a certain ratio. So you could do a quick sketch. P is 2, 1, and Q is 4 minus 3, so that's down here. And we want to find a line that divides that in the ratio 2 to 3, or a point, sorry. So this distance from here to here would be 2, and from here to here would be 3, and we want the coordinates of this point here, okay? And our formula is, when you look at the tables, it's bx1 plus ax2. So because we're looking for a point, we need an x coordinate and a y coordinate. So here's the formula for the x coordinate, here's for the y. So what you really want to do there, I'll just write it down, bx1 plus ax2 over a plus b, that's your x. Your y is by1 plus ay2 over a plus b. So we're trying to find the coordinates of this point. So when you go back here, these all have to change to numbers. So you want to make sure you label those numbers first. So the first point has an X and a Y coordinate. So write down your X and Y, and that's 0.1. So that's going to be X1, Y1. This is 0.2. So X, Y, and they're going to be 2's. And then this is your ratio. So that's A and that's B for the formula. So when you go back to do the formula, you're literally looking at each number here. B is 3 times X1 is 2. A is 2 times X2 is 4. A plus B is 2 plus 3 is 5. And then you do the same thing here. B is 3 times Y1 is 1 plus A is 2 times Y2 is minus 3 over 2 plus 3. And then that's 6 plus 8 is 14 over 5. And 3 minus 6 is minus 3 over 5. Okay, and that's 5 and 14, that's almost 3, and that's kind of just past minus a half, and you can see that looks roughly right there. Okay, we're about 3 and probably about minus a half. So make sure your answer makes sense. Is that okay? And the thing with all of these is the formulas are there. What you want to do is make sure you put the numbers in correctly. Okay, so the next thing is then to find the distance from a point to a line. And if you look at the formula for that, the line, this is one where we have to have the line in general form. So when you see here, the distance from the point to the line, AX plus BY plus C. So before you start, make sure that your line is written in the form AX, a number times X, a number times Y is C, and a 0 over here. Okay, so say, just say I was given my line is y equal to 3 over 2x minus 3, okay? And I want to get the distance from 2, 3 to this line here. This is not in the correct form. So the first thing I want to do is get rid of the fraction. So I'd multiply everything by 2. And then I want everything on the same side. So I'm going to take the y away from this side and bring it to this side. So now you've got 0, 3x minus 2y minus 6. Is that okay? So you make sure it's in the correct format that you can apply the formula. Now, when you write down the formula, it's absolute value because it's a distance, and a distance must be positive. So that's what these two lines are here. That means if this value works out as negative, you ignore the minus sign. You're only going to take the positive value of whatever you get here. So A, B, and C are the coordinates of X and Y and the number term. So A is 3, B is negative 2, and don't forget you have to include the sign, and C would be minus 6. And then X1, Y1 are the coordinates of our point. So that's X1 and that's Y1. And once you've identified those, it's just a case of putting them into the formula. So we've got 3 times 2 minus 2 times 3 minus 6 all over the square root of 3 squared plus negative 2 squared. And whenever you have a negative, put it in brackets. So that's 6 minus 6 minus 6. That's absolute value of negative 6 over 3 squared plus 4 squared is 13. That would be 6 over root 13. And you can put that into your calculator and it'll fix it up for you as 6 root 13 over 13, just to have it in proper form. Don't worry too much about that. As long as you use the calculator, it'll give it to you in the correct form. Is that okay? And then the final one is the angle between two lines. And for this, you're focusing on the slopes. So the formula for the angle between two lines is that the tan of the angle, and there'll be a plus and a minus here, and then it's M1 minus M2 over 1 plus M1 M2. And basically, the plus and the minus refer to the angle between the two lines can either be acute, less than 90, or obtuse, greater than 90. So if you remember, tan theta from 0 to 90 is going to be plus, and from 90 to 180 is going to be minus. Do you remember that from the unit circle? Like if I put in tan of any angle that's bigger than 90, I'm going to get a negative. So that's what the plus and minus means. So like if I do tan of 120, it's negative root 3. If I do tan of 150, it's going to be a negative. Okay? If I do tan of something less than 90, it's going to be positive. So basically every pair of lines will have two angles. The plus will give you the acute and the minus will give you the obtuse. Is that okay? That makes sense? Okay. So what we want to do is for this one, say we're using these two lines here, we need to get the slope. And remember the slope is negative a over b. So for this one, M1 would be negative 4 over 5. And this one, M2 would be negative 2 over negative 5. So that's 2 over 5. Is that okay? And then we just sub them into the formula. So I've got tan theta is plus or minus negative 4 over 5 minus 2 over 5 over 1 plus negative 4 over 5 times 2 over 5. Now and you can put that into your calculator. I would just put the plus in, take your fraction button, and you're going to do negative, which is this button here. I'll straighten up this thing. And you're going to have another fraction, so 4 over 5 minus another fraction 2 over 5. And then on the bottom, you've got 1 minus brackets, fraction, negative 4 over 5, brackets, 2 over 5. Okay, and close your brackets. And that gives you your answer. It's negative 10 over 11. Okay, is that okay? Is everybody happy enough using the fraction key on their calculator? Okay, and that makes it, you don't have to worry then about your common denominators and, you know, calculating all these. You can just, the calculator will do it for you. Okay. So that's our tan theta, and it could be either plus or minus this. Okay. So because if you're asked for the acute angle, then you just say it's going to be 10 over 11. If you're asked for the obtuse angle, you do minus 10 over 11. And I'll show you, we'll get the same answer. So if tan theta is this, then theta is the inverse tan of 10 over 11. So if I do inverse tan of 10 over 11, I get 42.27 degrees. And if I change that to a negative, that's where the problem is. Now, see the way, if you put a negative in here, the calculator is just going to give you the negative angle. So what you have to do is to get your obtuse angle, this is our reference angle. So if one of the angles is 42, the other angle is going to be 180 minus 42. Okay, so I'm going to do, so that's, the other angle is 137.73. And if I get tan of that, it will be minus 10 over 11. Okay, and it's the negative. All right, so that's why we need our ASTC and our reference angles, because the calculator can only be programmed to give us one angle, and it's programmed to give us the negative angle instead of the obtuse angle. Are you fine? Do you understand what I'm saying there? Anybody want me to go through that again? Okay, so if you put tan of negative into your calculator, you're going to get a negative angle. So just change it to plus to get the acute, take it away from 180 to get the obtuse. Okay. Now, a couple of other things that come up is the area of a triangle, which is the half x1, y2 minus x2, y1. I haven't filled them in on the notes yet. But basically, if you have any triangle, okay, and you want to get its area, so we call the vertices A, B, and C. Oops. And if you notice, this here, this could be, say, x1, y1. This could be x2, y2. And this could be x3, y3, because there's 3 points for any triangle. If you notice, the formula only has the 1s and the 2s. It only has 2 of the vertices. because, anybody know why that is? What do we have to know about the third vertex? What it is that the third vertex must be the origin. If you look at the formula and read it carefully, it says the area of the triangle OPQ. So one of the vertices has to be at the origin. And if you don't have a vertex at the origin, you shift the whole triangle down by the same amount so that it just moves down and everything is translated. So I'll give you a practical example there. So say we had, like, this is the point 2, 4, and this is the point 5, 9, and this is the point 7, 6, okay? And you want to get the area of that triangle. So what I would do is write my 3 points down, one under the other, okay? And what you need to do is move one of the vertices to the origin. And if you move the other two by the same distance, then you haven't changed the shape of the triangle. Okay, you've just shifted it. So in translating this point, say we move this to the origin, the x coordinate is going down by 2 and the y coordinate is going down by 4. Does that make sense? So to get from here to here, you do 0 minus 2 is -2, 0 minus 4 is -4. Does that make sense? Okay, so then what we want to do is move the other 2 points by the same amount. So I'm going to do 5 minus 2 is 3, and 9 minus 4 is 5. I'm sorry, I don't know why I wrote 7. 7 minus 2 is 5, and 6 minus 4 is 2. So this is my new triangle. And now I have a triangle with one of the vertices at the origin. So I can call this one x1, y1, and this is my x2, y2. And then to get the area of the triangle, I do a half x1, y2, which is 3 by 2, minus 5 by 5. And you notice again, we're using our absolute value because it has to end up being a positive number. So that is 6 minus 25, which is -19. I ignore the minus, so that's 19 over 2, or 9.5 units. Is that okay? All right, so the translation is easy enough. I can show you on Desmos that it actually, bear with me a sec. And then the final thing you want to know is the centers of a triangle. So I'm going to run through those now. So the 3, they're called concurrencies because concurrent means they're at the same point. So it's 3 lines in a triangle that meet at the same point, and we're trying to find that point. And the 3, they're basically 3 different versions or centers of a triangle. Okay, I'm just going to use that for triangle. And the 3 are the centroid, the circumcenter, and the orthocenter. And these are not in the table. So this is one thing you have to remember yourselves. So the centroid, and all of these are intersections of lines. That's the point of intersection. So they're all points of intersection. This one is the point of intersection of the medians. This one is the point of intersection of the perpendicular bisectors of the sides. And I'll go through what each of these means in a minute. And this one is the point of intersection of the perpendicular from a vertex to the opposite side. Okay, and I'll do a little video with the 3 of these, but just to show you what I mean, if you have a triangle, okay, the median, does anyone know what a median is? The line, do you know where it starts and ends? Anyone remember what a median is? Okay, so you start at one vertex and you go to the midpoint of the opposite side. So say I have A, B, C here, okay? So if I was getting the median, I would get the midpoint of BC, which would be about here. I'm just doing this roughly, and I would join A to that, and that would give me one line, okay? And then I would get the midpoint of another side, so the midpoint of there is about roughly here, and I would join that to the opposite vertex, okay? And then I get the midpoint of this side, and I join that to C, and the 3 of them actually intersect at the same point, and that's the centroid of the triangle, okay? So in practical terms, if you had to go through this, basically you want to get the equation of this line and the equation of this line and find their point of intersection. And to get an equation of a line, you need 2 points in the line. So the point is the vertex and the midpoint. And you get the equation of that line, and then you do the same for another vertex and the midpoint of the other side. However, there's actually a nice little formula for this to save you having to go through all that. It's just because this centroid is the exact center of the triangle, so it's the average of the 3 x's and the average of the 3 y's, and that's the coordinates of that point there that's right in the center of the triangle. Okay? So it's not a difficult formula to remember. If you just remember the centroid is the average of the x's for the x coordinate and the average of the y's for the y coordinate. Okay? And the one other thing I want you to remember about medians is that medians, and this is a kind of aside, but it does come up in questions, medians divide each other in the ratio of 2:1. So if this distance is going to be twice this distance. So this is in the ratio of 2:1. This distance is going to be twice this, and this is going to be twice this. Okay? So that's just another kind of thing you should remember about medians. The circumcenter, that's the center where you can draw. So if we have our triangle again, you could draw a circle that goes through the 3 vertices, okay? That's what the circumcenter is. So it's the center of that circle that goes through all 3 vertices. And for that reason, if you were to draw a line, it has to be the same distance from all 3 vertices, okay? So this, and this would all be equal, okay? And that means that center has to be the same distance from here, and the same distance from here, and the same distance from here. And that's why you get the perpendicular bisectors. So to find the circumcenter, let me just see if I have here. What you would do is say this is your A, B, C. The perpendicular bisector means it's a line that goes exactly through the middle. Okay, so if we're looking at this line here, we want a line that goes through the midpoint. So we find the midpoint. Okay, and that's going to be our point on our line. And then we get the slope of BC. Then we get the -1 over that is going to be the slope of our perpendicular. Do you understand what I'm doing there? Let me just see. Yeah, I'm just going to take a triangle and do it out for you. So say we had the points. So say we've got -2, -3, 4, 9, and -4, 3. Okay, and a quick sketch of those. -2, -3 is about here. 4, 9 is kind of up here. and minus 4, 3 is about there. Okay, so there's our triangle. All right. And what I'll do is I'll use this triangle to work out all three. So if I just want the centroid, I add up, so minus 2 plus 4 minus 4 over 3, and minus 3 plus 9 plus 3 over 3. So I'm just getting the average will be the centroid, and that's 4 minus 4, that's minus 2 over 3, and 9 over 3 is 3. So that's going to be about here, okay? And if you look at those, they're all divided in the ratio 2 to 1. So that's roughly the centroid. And that's easy to work out. The circumcenter is a little bit trickier. And you do the same process for two of the sides. So we want two lines and to find where they intersect. So say we pick AB, we want the perpendicular bisector. So we first of all get the midpoint. Okay, so here's A and B. So the midpoint would be minus 2 plus 4 over 2 and 9 minus 3 over 2. Does that make sense? That's 1 and 3. Okay, so that's the midpoint of AB, about here. And then we get the slope of AB. That's y2 minus y1, so that's 9 minus minus 3 is 9 plus 3 over 4 minus minus 2 is plus 2. So that is equal to 12, that's equal to 2, okay? So the slope of the perpendicular to AB, because I want to remember the perpendicular bisector is going to be the negative reciprocal of that, so it's going to be minus 1 over 2. That making sense so far? What? To get this circumcenter, what I have to do is get the equation of a line that goes through the midpoint of AB and is perpendicular to it. And then one that goes through the midpoint of AC and is perpendicular to that. And where they intersect, that would also be perpendicular to the midpoint of this line here. And they'll all intersect at the same point. But I don't need to do all three intersections, I just need to do two of them. So to get the line that goes through the midpoint of AB, I need the point and the slope. So the midpoint, I work out, the slope is going to be the opposite of the slope of AB. Does that make sense? And then I get the equation of that line using y minus y1 is equal, so this is our standard equation of a line. So you have y minus 3 is equal to m, which is minus a half times x minus 1. Get rid of the fraction, so I've got 2y minus 6 is equal to minus x, minus 1 by minus 1 is plus 1. And if I put that in general form, I would have x plus 2y minus 7 equal to 0. And that's one of the two lines I want, okay? Now I have to do the same thing for one of the other sides. So say I use AC, all right? So the midpoint of AC, so A is minus 2 minus 3, so the midpoint would be minus 2 minus 4 over 2 and minus 3 plus 3 over 2. That equals minus 3, 0. So that's going to be my x1, y1 for this line. And then the slope of AC, y2 minus y1, so that's 3 plus 3 over minus 4 plus 2, which is 6 over minus 2 is equal to minus 3. That's the slope of AC. I want the slope of the perpendicular. So the slope of the perpendicular to AC is plus, because this is minus, and then it's 1 over 3. Is that okay? And then I get the equation of this line. So y minus 0 is equal to 1 over 3 times x minus minus 3 is plus 3. Multiplied by 3 to get rid of the fraction, and you can forget about the 0. So that's x plus 3. So that gives me this equation is x minus 3y plus 3 is equal to 0. And that's my second line, okay? And then I find where those two lines cross each other by simultaneous equations. So if you look at equation 1 and equation 2, I want equal opposite coordinates. So if I just change all the signs in this one, so minus equation 1, I'm just going to, rather than write them all out again, I'm just going to write this one down underneath, but change all its signs so that the simultaneous equation works out nicely. Is that okay? And then if x minus x cancels, minus 3 minus 2 is minus 5y plus 10 equals 0. So minus 5y is minus 10, so y is equal to 2. And then I sub that in here. So equation 1 would give me x plus 4 minus 7 equals 0. So that means x is equal to 3. And the point 32 is the circumcenter of my triangle. And I'll just kind of roughly draw the triangle out again, just so you can see. Theta A was minus 2 minus 3. B is 4, 9. Right up here. C was minus 4 plus 3. It was about there. Okay. So the perpendicular bisector of AC was kind of, and I'm roughly drawing that. I find the midpoint and I went straight perpendicular to it. We found the midpoint of AB, 1, 3, which is about there and through that. And where they intersect, 0.32. No, that doesn't look. 3, 2, about here. Yeah, I'm a little bit off in my drawing. Okay, so they intersect about here. And sometimes you'll find that the center is actually outside the triangle. So if I was to take my compass and put it to any corner there, I would draw a circle going through the 3 points, and the center of the circle would be that point. Okay? This isn't very accurate, obviously, but does that kind of make sense to people? Okay, so it's long-winded, but there's nothing there that you haven't done before. You know how to find the midpoint, you know how to get the slope, you know how to get the equation of the line, and you know how to do simultaneous equations. So what I'll do is I'll do a kind of video of those finding the centers just separately to go along with the notes, because it's a bit long-winded, but it's not actually difficult per se. There's no kind of hard maths in it. It's just pain in the neck. So we've one class left on Monday. Is there anything you guys want to go through in particular on that?
No, I mean, I'm kind of fine.
Okay.
For IXL, do we just go over like what's on each
What I
chapter?
can do is what I'll do is where I have these things here, I'll put in IXL topics and brackets after them.
Okay, cool.
Okay, yeah, I'll do that now.
Oh, and Miss,
Yeah.
I won't be able to print out the test. The printer in my house is
Okay, well,
broken.
what I've done is a kind of short version of it then for if you can't print it out, so you'll be able to see it all on maybe 2 pages on your phone rather than spread over the 4.
Okay.
That okay?
Yeah.
And then just do it in your copy and send it back.
Yeah.
So short version, long version, and I'll put up a link to the maths tables online in case anybody's missing their maths tables.
Grand.
Yes, you can print it out, just do it in your copybooks, that's fine. Okay.
Thanks, Miss. Yeah.
All right, have a good weekend, lads.
Thanks, Miss.
Okay, take care.
Thanks.